Hi students, today the fifth sum in the textbook exercise. In the circuit shown in the figure, the bipolar junction transistor has a current gain beta equal to 50 for an emitter base voltage VEB equal to 600 millivolt. Calculate the emitter to collector voltage VEC. Very simple numerical problem it is. We have to understand the circuit very well. So what is given? First I have written what is given here. The emitter to base, the emitter base potential difference is 600 millivolt. So milli means it is 10 power minus 3. Therefore 600 into 10 power minus 3 will become 0.6 volt. Then the beta gain of the transistor is 50. Okay. Here what type of transistor is given we have to analyze first. Always the conventional current will be shown in which branch of the transistor is emitter. So you have to note down that here this is the emitter and this is the base and here is the collector. So when the conventional current is flowing from the emitter to collector, means then what type of transistor is given here is PNP transistor. This time it is PNP transistor. Input, base is the input terminal. In the output, emitter is connected. So which is kept common is a collector. So this is a common collector mode. First of all, we have to understand this. So a PNP transistor connected in the common collector configuration is given in the circuit. Okay children, what do you mean by VEB? It is the potential difference between the emitter and the base, emitter base junction, input PN junction, understand? So this is the emitter, this is the base. So in between this emitter and base, the potential difference is VEB. Okay. Now you can see that the base is grounded. Grounded means what? 0 volt. This resistance now is connected to ground, 0 potential. Okay. So now the emitter is connected to plus 3 volt. So I can now consider the emitter potential VE. The emitter potential is equal to what? 3 volt. So VE is equal to 3 volt and V emitter base junction VEB is equal to 0.6 volt. 0.6 volt. So here the potential difference is 0.6. So if you measure the potential difference of between this point and the ground, it is 3 minus 0. It is 3 minus 0. Is it not? Like that, if you measure the potential difference between here, this point and the base, the value is 0.6. Is it not? Therefore, I can write this VEB is equal to VE minus VB, or VB is equal to VE minus VEB. I can write like this. Okay. So what is VE here? VE is 3 volt. The emitter is at a potential of 3 volt. So this is equal to 3 minus VEB is given as 0.6 volt. So 3 minus 0.6. Therefore, the first information we have collected is the base potential is equal to 2 minus 0.6 is 2.4 volt. So this is the first result we have arrived. So the potential at B, the base B is 2.4 volt. So what do you mean by that? If you take a multimeter or voltmeter and measure the potential difference between this point base and the ground, the potential difference across this resistor, the potential difference across this resistor is equal to how much? 2.4 volt. Okay. So this is 2.4 volt. Okay. As a result, a current will flow in the base. Okay. From the base to the ground, a current IB, base current is going to flow now. And this resistor is taken to be what? R base. So a potential drop has occurred across this resistance of 60 kilo ohm. So this 60 kilo ohm is the base resistor, and what current is supplied through the base I have taken as IB. So this potential difference of 2.4 volt must be equal to the product of IB into RB. Understand? So I will write IB into RB is equal to this VB. Okay, VB. Okay. Therefore, IB, the current, base current IB must be equal to VB divided by RB. That is, IB is equal to, what is VB here? It is a 2.4 divided by RB is how much? 60 kilo ohm, is it not? 60 kilo. So I can write this as 6 into 10 power 4, because 60 into 1000, is it not? 60 into 1000 can be written as what? 6 into 10 power 4, or this also can be written as, here 2.4 can be made as 24, and this 10 power 5 I can adjust. So this is also equal to 24, okay, divided by, multiplying both sides by 10, 2.4 becomes 24 and 10 power 4 becomes 10 power 5. So this is 6 into 10 power 5. So that this is equal to 6 4s are 24. 4 into 10 power minus 5, or this is equal to 40 into 10 power minus 6 ampere. Why I have to do like this? To adjust the terms, because 10 power minus 6 ampere is equal to 1 microampere, is it not? Therefore, now I base, what is the base current now? It is equal to 40 microampere. So that is the second result we have to arrive. Okay children, you see that the base current therefore is equal to what? 40 microampere. Okay, have you all understood up to this? Okay, up to this step have you all understood? So first we determined the base voltage, base, okay, then we equated with IB, RB. Now the base current we have determined. Okay, next step we have to find what current is flowing through the collector. Okay, through this collector resistor, IC is the current flowing. Understand? And this is the resistance at the collector RC. Okay children? So what is the value of the collector current is the next step we have to do. So for that the clue is beta gain is given, is it not? Beta gain is given. So what is beta gain? Beta gain is equal to collector current divided by base current. Is it not? So what is collector current therefore equal to? Therefore collector current must be equal to beta times IB. So beta is given as 50 into 40 microampere. So here we have to multiply 50 into 40. So 5 4s are 20. Remaining 2 more zeros are there. So it is 2000. So this is 2000. That is 50 into 40 is 2000 microampere. So this is 10 power minus 6. So this is also equal to 2 into 10 power minus 3 ampere. Therefore the collector current is now equal to 2 milliampere. So this is the third step of this problem. So systematically we have to determine the base current, then the collector current. Okay children, now collector current we have found as 2 milliampere. What is the collector resistor here? 500 kilo ohm. Is it not? So what is the potential drop or the voltage drop across this collector resistance? So IC into RC. Okay, IC into RC. This product I want to find out. So IC into RC is equal to what? 2 milliampere. That is 2 into 10 power minus 3 multiplied by RC is 500 kilo ohm. Is it not? Actually, in this problem, by mistake they have given 500 kilo ohm, because this much value of the resistance cannot be applied here. Therefore, the textbook itself they have given this mistake as kilo ohm. So what we have to do is we have to eliminate this. Okay, it must be actually 500 ohm only. So I am going to substitute here 500 ohm only. Okay, it's a textbook error. So here I will multiply this by 500. Okay, now 500 into 2 is 1000. Is it not? So this is equal to 1000. 500 into 2 is 1000. 1000 into 10 power minus 3 is how much? 1000 into 10 power minus 3 is 1. It is simply 1. So IC into RC is equal to 1 volt. Okay. So what is the potential difference? See what I told you, my dear children. If you substitute 500 kilo ohm, 500 kilo ohm means what? 1000 volt it will become. Is it not? This value will become what? 1000 volt. Can a transistor withstand 1000 volt first of all? So we have to understand there are some errors in the circuit. Okay. So we have corrected. So if you take 500 ohm, how much voltage is developed across this collector resistor is 1 volt. Applied voltage here is 3 volt. Out of that 3 volt, 1 volt is dropped across this resistance. Means what should be the remaining voltage between the emitter and the collector? That is the question. That is the question in the problem. What is the emitter to collector voltage? It must be naturally this 3 volt minus 1 volt. Is it not? Very simple. Therefore, now you see here, this can be taken IC into RC also can be called as what? VC, collector voltage. Already what is the emitter voltage? Here emitter potential is 3 volt. So V emitter to collector VEC must be equal to VE minus VC. So in the circuit VE, here VE is equal to 3 volt. So here I will write this is equal to 3 volt minus VC is IC into RC. Is it not? That is equal to how much? 1 volt. So this is equal to 2. Therefore, the final answer is emitter to collector voltage is equal to how much? 2 volt. So this is the fourth step in our problem. This is the correct answer given in our textbook. Understand, children? I hope you must have understood well. Fine.